Okay, we're going to do another math video. My last video was on least common multiples, and I was working with two fractions. This time I'm going to show you how to do it with three fractions, and this is where it becomes kind of critical that you use the prime factorization method instead of trying to multiply out your denominators to get your least common multiple. It gets really hairy if you don't have cool ninja tactics to handle these multiple fraction problems. So I've got a real simple set of fractions on the board right now: 1/6, a 1/8, and 1/10. And I'm going to bracket prime factor these. That's what I call it. I'm sure there's a technical term for it, but just watch. I start with my 6 and I throw an upside down division bar around it, and I find a prime number that goes into my 6, and I'm going to use 2 and 3. 2 goes into 6 3 times. That's how I got that. So the prime factored form of the denominator 6 is 2 times 3. Okay. Now I've got 8. And I'm going to go ahead and prime factor that in the same manner. I'm going to do my 8 upside down division bar in 2, because it's an even number. 2 goes into 8 4 times. Another upside down division bar. 2 goes into 4 2 times. So I have prime factored that as far as I can go. So the prime factored form of the denominator 8 is 2 times 2 times 2. Okay, 10. 10's a simple number. You shouldn't even have to bracket for this, but it's 10. We're going to do 2, and 2 goes into 10 5 times. Those are both prime numbers. That's the goal here, is to get prime numbers, numbers which can only be divided by 1 in themselves. So the prime factored version of 10 is 2 times 5. Alright, in the previous video I showed you how to choose the number that has the denominator that has a number that has the most instances of that number. So for the number 2, every single fraction here has the number 2, but 1/8 has the most number 2's. So we're going to keep those. There's 3 of them. And we're going to cross out these because they lose. They're just losers. So we're going to keep the 3 2's here. And then we've got a lonely 3 over here, and there are no other 3's, and we've got a lonely 5 over here. So now we bring all these little numbers that we circled are prime factors, and we're going to create an expression that will give us, an equation that will give us the answer, the least common multiple for all 3 of these fractions up here. We're trying to find a denominator that will be the same, something that we can turn these fractions into something, manageable numbers that we can add or subtract with. So if you plug in 2 times 2 times 3 or whatever, let me grab my calculator real quick. I believe it comes out to 120. Hold on, 2, 2, 2, 3, 5. Let me just verify. 2 times 2 times 2. A little planning would help. Times 5 equals, look at that, 120. I did that in my head. Alright, so 120 is our lowest common multiple for the fractions 1/6, 1/8, and 1/10. Now, just to prove to you why this method is infinitely better than the just keep adding until you get a match method, I'm going to go ahead and do it. It's going to be long and tedious, and I'm going to go really, really quick. So we're going to start with the denominator 6, and we're going to do our multiples: 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, no, 54, 60, 66, 72, 78, 84, 90, yeah, 90, 96, and I'm looping around here, 102, 108, yeah, it's pretty, whatever, 114, and finally we get to 120. I'm just going to stop there because over here it kind of says that that's what it's going to end up being. Alright, now we're going to do 8. 8 is our next denominator over here. See? 8. So we've got to do it the kind of like ghetto funky, awesome, really slow method, just so I can prove to you why prime factorization is so important. So we got 8. 8 plus 8 is 16. Plus 8 is 24. Plus 8 is 32. Plus 8 is 40. Plus 8 is 48. Plus 8 is 56. And 64. And 72. 80. Right? 72. Yeah. 80, 88. 96. 104, 112, and 120. So there's our match, right? Now, you might get alarmed because you see a couple matches, you've got 48 here, and you've got 48 here. Boop. But that doesn't account for 1/10 over here. You still have to find a least common multiple for that 1/10. So, you know, you might be like, oh, 48, but 10 doesn't go into 48. So if you do 10, I don't really have to do this, but you go 10, 20, 30, blah, 100, 110. Oh my gosh, look, 120. Okay, so now we've got our common denominator. Right there, 120. This is a lot of frickin' work. This is a lot of tedious... This is the type of work that makes people hate math. Math should not be hated. Math is a lovely thing. This is why people go crazy and be like, screw math, because of shit, stuff like this. Excuse my French or whatever. This is happy math. This is math that puts you in control of your, you know, mathematical future. It feels a little bit more manageable and less just, you know, oh my god, all the work. It's really not that much work if you just know a couple neat tricks. So there's that. Let me clear this off and we're going to do another horrendous one. So basically I've just proven that you can use both methods, but there's some instances where the method on the right is going to just, it's going to kill you mentally. You're going to like be throwing horrible things at your neighbors and lighting them on fire. The prime factorization method is fabulous. So I'm going to go ahead and clear off my screen and start a new problem. And I'm going to use some really wonky fractions. And this is just basically extreme review, you know, like sadistic, or I'm sorry, masochistic math for some people, but I want to take really nasty numbers that, you know, you've got, I don't want that number. That's not going to work well. No, stop. What is my thing with 5s today? I need a 2. Somebody wrote 2. Okay. So you got 24, 68, and 52. Someone please tell me what my least common multiple is. Go ahead and do the multiplication in your head of 52. Or 68 or 24. Well, 24 might be easy. But 68 and 52, not common everyday numbers that we need to know the multiples of. So, yeah, you need to find an easier way to do this if you don't have a calculator. And I've gone over previously why you're not always going to have access to that. Prime factorization. It's there. It rocks. Let's do it. Alright, so 24. 24, upside down bracket. 2 goes in there 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. 3 times. Yeah, most of my trouble on my math homework comes when I do stuff like that. Randomly create numbers. 2 times 2 times 3 is the prime factored form of 24. Alright. 68. Upside down bracket thingy, 2, 34. 2 goes into 34, 17, 17's prime. Oops, 17. Alright, 52. 2 goes into 52, 26 times. And 2 goes into 26 13 times. Another prime number. Again, we want to get our prime numbers on the outside. So prime factored form of 68 is 2 times 1 7, 17. Prime factored form of 52 is 2 times 13. We're going to play the who's got the most of stuff game. Let me erase this because it'll be confusing. Which fraction has the most of a certain number? So we'll start with our 2's. And if you look, 52's got 2 2's. 68's got 2 2's. Haha, 2 2. And 24's got 3. So 24 wins the battle of the 2's, and we obliterate the other groups of 2's. Now the only thing that's left are orphan numbers. We've got a 3, a 17, and a beautiful little 13 over there. And what we're going to do is create an equation that will give us our greatest, or our least common multiple, our common denominator for these 3 fractions up here, 1/24th, 1/68th, and 1/52nd. So 2 times 2 times 2 times 3 times 17. 17 goes over there, times 13. Nope. And this is going to come out to some hideous number of 5,304. And that, yeah, that's going to be your common denominator if you were to add or subtract these pretty fractions up here. So this is where prime factorization is a really good little skill to have in your back pocket, because if it wasn't for prime factorization and having this technique, you'd be adding 52 so many times until you got to 5,304. Yeah, that's pretty horrendous. So that's why I love prime factorization. Okay guys, thank you for watching. I hope I wasn't too bizarre or rambling or didn't swear. I don't remember. Anyways, if you have any questions, comments, critiques, complaints, you want to see me work out a problem you have up to a certain level. You know, I'm not like in advanced calc or anything yet. Let me know, and I will try to make a video about it. Alright, thank you. Have a great day, and hopefully I taught you something.